So that's number 12 out of the way. You can't hardly see it. I had to box in the number so I could do it. Number 13. Guys, please, please, please. This is why it's so important to know all three methods. You will use a boatload of time doing this problem if you try to do it with elimination method. You'll use a little bit less time, but still a lot if you try to do this. Actually, probably more, really. It's going to be harder with substitution. This is a graphing problem. Y equals Y equals. When they're both already solved for Y, like these two are, please, please, please just graph it. And I don't even need to see your graph like we had on number 1 and 2. You already showed me you could do that. I'm just concerned with the answer here. So I'm going to clear out whatever someone left in the calculator. Alpha Y equals enter. 3 over 4 x minus 1. Just do a quick double check. Make sure I'm typing this in right. Negative alpha Y equals enter. 1 over 2 x plus 4. Do a quick double check. 3/4 x, 3/4 x, minus 1, minus 1. Negative 1/2, negative 1/2 x, plus 4, zoom 6. There's my intersection. It looks like it's at 4, 2. Don't trust your eyes, trust the calculator. It can do that. Second trace, which brings us to this blue calc menu. And we go down to number 5, or press 5, press enter. And then it's going to say first curve. Yep, that's our first curve, press enter. Second curve, yep, that's our second curve, enter. We don't guess, just press enter. And it is at 4, 2. Guys, that's a 30-second problem. Maybe not even that long for some of you. 30-second problem. Do not make that one harder than it has to be. Number 14. I look down here at this, I go, oh boy, that's definitely not a graphing problem. It could be a substitution problem, but nothing's solved. I don't have a variable all by itself. And then I notice, hey, these are stacked up on top of each other pretty nicely. And I know I can make a 10 into a 20. So I'm thinking already now, this is probably another one of those dang elimination problems, okay? Speaking of which, to do that elimination, like I said, you can just take this and turn a 10 into a 20, but I want a negative 20 so that they'll cancel. Negative 2 is our multiplier, okay? When I do that, I get negative 20x minus 14y equals, I'm writing that too small. I'm just going to write this all over and get out here to the side, okay? So let me erase part of that. Apologize if you need that, just go back. My top equation remains the same. It's going to be a 20x plus 6y equals 10. I was going to try to write it under here, my next one, but it's going to get too small. When I multiply here, I get a negative 20x, I get a minus 14y, and I get a positive 30. Don't believe me? Ask the calculator. Be careful there. That's a lot of negative signs flying around. Negative 2 times negative 15 is positive 30. Double check yourself, okay? When I add these equations together, these x's are going to cancel. That's good. That's what we wanted. That's the whole point behind elimination method, all right? Get that cancellation going. When I add these, I'm going to get a negative 8y equals 40, and that starts, alarms start going off in my head that this problem is working out pretty well because 8 goes into 40 5 times. But when I divide by a negative and divide by a negative, that's going to become just a y, and this is going to become a negative 5. Okay? That's half your answer. Half your answer. To get your other half, you plug that piece in. I'll plug into either one of them works, either equation, and really neither of them is a whole lot easier. Some people are going to choose to plug into this top equation because they're all positive. Others are going to choose to plug into this bottom equation because the numbers are all a little bit smaller. I'll use the top equation. Again, it does not matter. I have a 20x plus 6y equals 10. And I know that y equals 5. So I use that information and plug it in for y. 20x plus 6. Now again, my y is a negative 5 equals 10. So that gives me 20x minus 30 equals 10. I'm going to add 30 to both sides. Gives me 20x equals 40. Divide by 20, divide by 20. And that's going to be a nice even x equals 2. That's the other half of my answer. So my full answer is 2, negative 5. Make sure you indicate that somehow. Square it in. Put a star by it. Something that lets me know, as the person grading it, hey, that's my final answer. 15 is probably the most divisive problem. Like well, that's probably not the best way to put it, but the way people do a problem like 15 is going to change drastically from person to person, because you could really attack this two different ways. Those ways being graphing or elimination, or I'm sorry, graphing or substitution. But some people are just stuck on elimination, and that's the best one. So they're going to do this whole section with elimination. That can work. You got to just line everything up. We haven't looked at a whole lot of that. I used to teach a lot of that where you have to work on lining them up for elimination. But really, if it's not lined up for you, I would suggest you not use elimination. Okay. And in this case, they're not lined up. It's not standard form like it was in the previous problem. Okay. I, though, notice, hey, I've got a y by itself. Maybe I can graph it. Oh, wait, this y isn't by itself. Graphing kind of goes out the window. Now, could you solve this bottom equation for y? Sure, and then you graph it. But if I only have one variable solved for itself, I'm looking back and thinking back to whenever on numbers 6 and 7 when it told me to substitute. Whenever it told me to substitute, it gave me only one variable by itself. So I'm thinking, hey, maybe that's exactly what we're trying to do on this bottom problem. I'm going to take the fact that y equals negative 3x, and I'm going to plug that negative 3x into my other equation. And where do I plug it in? For y, of course, because y equals that amount. Whenever I do that, I rewrite my bottom equation, negative 2x minus 5, but instead of y, I'm going to plug in a negative 3x. And then I continue writing the equation, equals negative 17. Okay, because you do it by graphing, sure, and I'll show you that one briefly, but the real way this one probably should be attacked is by substitution. Now I have 2x minus a negative 5 times a negative 3 is a positive 15x equals negative 17. Combine like terms, 17x equals negative 17. And when I divide by 17 on both sides, I get that x equals negative 1. Okay, so it wasn't too tough of a problem. That's half my answer. To get my other half, I want to plug that in. And if I have an equation that says y equals all of this, I'm going to plug that into there because that's going to tell me what y is. So the other half, I have y equals negative 3x. Well, I know that x is a negative 1. I'll show you a negative 1. I kind of drew my line through it. I apologize. Okay, because remember, we divided by 17, x equals negative 1. And when I circled it, I kind of accidentally just got rid of my negative sign, I think. Like I did there. Negative 1. So we have y equals negative 3. Plugging in a negative 1 for x. Negative 3 times negative 1 is just a positive 3, giving me my answer, negative 1, comma 3. All right.